All right, so based on what we've talked about changes in A, H, and K. Identifying these transformations just occurs by looking at each part and saying, hey, this is a negative A value. That means it opens downward. Then looking at 2/3 and saying, okay, this part, 2/3, the A value is less than 1. So this will be wider, or what we might call a vertical compression. H, if it says +4, remember that +4 means it would be a negative H value. So that means we move 4 units to the left. And if I'm looking at the -3, that's a negative K, so that means I'd be going down 3 units. Okay, so each part can tell you what the transformation is. So you don't have to know them all at once. I'd start at the left and work your way over to the right, and that way you are not trying to figure it all out at the same time. You're just looking at each piece and identifying the transformation that it means. So, for instance, 8/3. Well, this is positive, so we still know it's opening upward, so I don't need to really write that down. 8/3 is bigger than 1, so it is narrower because the value of A is bigger than 1, so it's narrower, or what you might hear called a vertical stretch. -1 means that it looks like this, right? So it's a positive H value. So we moved right 1. And then +K, +9 means we're moving up 9 units. So when we're looking at this, when we look at this one right here, which part is missing from the vertex form, if you will? It's not really missing, it just, because you don't see it, it means the value is 0. So we don't have x minus anything or x plus anything within parentheses, so we're not moving left or right. But if we see a negative, what does that tell me about my quadratic? My negative tells me it opens downward. The 7 is a lot bigger than 1, so it's going to be narrower, and -12 is in the K space, so that tells me it went down 12 units. No change in H means it didn't go left or right. Well, we can take that information and we can also write equations of quadratic functions in vertex form if we know the transformations. So each one is always going to start with f of x equals or y equals. If we think about it from left to right, y equals, remember, a times x minus h squared plus k is the form of the quadratic function. So remember, a, if it's saying reflect across the x-axis, that's actually what we're saying, it opens downward. Okay, so this means opens downward. So what does that tell me about my A value? It tells me it's going to be negative. Okay. Does it say that it is vertical stretch, vertical compressed, narrower, wider? I don't see anything in there. So A is just going to be -1 because 1 didn't change. Then we can say, okay, X. H has to do with if it's going left or right. This says left 2. So remember, if it's going to move left, it's going to say x plus the number. So x plus 2. And it goes up 7. That changes the k. So we're going to write +7. Okay, so even if they write it in whatever order they write it in, you might be looking for those cues that tell you how to write it from left to right. The first thing we're looking for is A. The A changes up or down a reflection. A being bigger than 1 means it's narrower. A being less than 1 means it's wider. So you're looking for those things first. Okay, so Y equals, okay, that's H. Okay, vertical stretch by a scale factor of 4. That tells me that A is 4. Now it doesn't say it's reflected or opens downward, so I don't need to change the sign. It's going to stay 4. X minus 3, because it's going to the right, squared. Down 2 means minus 2. And remember, when it's talking about scale factor, we're always talking about multiplication, and that's kind of why the moving left or right is all adding and subtracting, but the scale factor is the multiplication, and A is the only really thing being multiplied in the vertex form. So Y equals, now it says a reflection, so this means open downward. Okay, so we're going to have a negative A. It's got a scale factor of 0.35. And then my X is moving to the left, and it's moving down 3. Okay, so you're going to need some practice with this. I don't expect it to be really intuitive at this point. But understanding transformations from the parent function can help us understand any quadratic, because the vertex gives us that starting place for when we're going to graph. And whether that opens up or down can tell us kind of more about the context of what we're talking about.